Okay, so I've on from the last question there, if we worked out the cube of 4.3, it should be 79.507 cubes, units cubed. So that's how many cubes would fit into that space. So for the 30 cubes here, when we cube root it, the side lengths of each of the length, width, and height should be about 3.01 dot dot dot. That number is important to recognize. That is an infinite decimal that does not repeat. So that happens to be an irrational number. So we'll talk about that a little bit later as well. So in general then, if you take a look at the length of the side of cube A versus cube B, the cube B is not, the side length is not rational. Okay, it is an infinite decimal. It's an infinite decimal, okay, which is what we call an irrational number, a number that can't be put into a fraction. Okay. So this is a big idea here. How is the cube power related to the cube root? Well, the cube power and the cube root are opposites. Okay, so one undoes the other, just like times and divide, add and subtract. So they are opposites of each other, and they are what we call mathematical opposites, and which is very important to understand this idea of opposites. The technical word for this is called an inverse operation. We can undo one with the other. We undo a cube power with a cube root. We can undo a cube root with a cube power. And then we could also say, in general, an nth power and nth root are also opposites. So if I have something like this, x to the power n, and the nth root of x, they are opposites of each other. Okay, so again, they are opposites. And they are what we call inverses. We can undo any power now. So although we're going to focus on cubes, we can do this with any power. We can go to power 4, power 5, etc. So the main idea again also is that what are we dealing with when we cube it? When we cube something, we're starting with a side length and we're ending up with volume. So we start with 3 centimeter side length. We're going to end up with 27 cubes of volume. The cube root is opposite. We start with the volume. If we cube root it, we end up with side length. So if we start with 64 cubes of volume and I cube root it, we end up with 4 centimeters of side length. Okay, so on your calculators, we can work this out. Okay, so if I want to find x, well, the problem with x here is I have x inside a cube root. I really don't want the cube root. I want just x. So how I would undo this is, well, I take the opposite of the cube root, which is cubing something. But this is a balance. If I cube one side, I've got to cube the other side. So the cube and cube root on this left side cancel out, so I'm left with an x. And on the right hand side, I end up with 5 cubed, which is 125. So the opposite would be true here. I've got a cube. I want to undo this cube with a cube root. If I cube root one side, I've got to cube root this side. So what number multiplied by itself 3 times gives me 64, negative 64? Okay, we can do this on our calculator, but we could probably do this without a calculator. Think some number times itself 4 times. Well, it's going to be 4 multiplied by itself 4, but that gives me positive 64. But if I want negative 64, I have to start with negative 4. So my side length, well, we can't really talk about side length, but when we talk about here, we're going from the volume. We're trying to find out the volume here is 125. Here we're trying to find out the side length, which was negative 4. So when we are estimating cube roots, we really need to have some standards to work with. So you need to know your perfect cubes. Now, by memory, I think it's by grade 8, we really should know up to there. Okay, up to 4 cubed is 64. We probably should be familiar with these, but sometimes, if you have to go to a calculator for these ones, it's not too bad. But if we have 1 cubed equals 1, the cube root of 1 equals 1. 2 cubed is 8, the cube root of 8 is 2. 3 cubed is 27, the cube root of 27 is 3, etc. Okay, so we want to make sure that we know our cubes, perfect cubes and cube roots, because that then allows us to have some standards which we can use to estimate. So I put these on a number line. On the top is the cube root scale. Along the bottom is the whole number scale. Okay, so if I want to know where cube root of 24 is, well, I know that it's got to be bigger than the cube root of 8. So the side length on the bottom here, to get a volume of 24, I have to have a bigger volume than 8. But I also have to have a smaller volume than 27, so it's got to be in here. So my side length has got to be between 2 and 3. So I'm just going to kind of put anywhere in between is going to be good enough as an estimate. So cube root of 24 is going to be right about there. And when I put that into my calculator, if I do cube root of 24 on my calculator, I'm going to end up with a decimal value of 2.88. Yeah, that is about right. Yeah, it's going to be in between 2 and 3. And as an estimate, we really just need to be in between those whole number references. And our calculator is going to confirm that. So for cube root of 51, we know it's got to be a bigger cube than 27, smaller cube than 64. So our side length has to be between 3 and 4. So I'm going to put that somewhere in here. Cube root of 51. And then I'm going to check that on my calculator. The cube root of 51 is going to be about 3.71. It's 0.8 something, but and we know it continues. I'm going to round that to about 3.71. The cube root of 100, okay, well, it's not the square root, so it's not going to be 10. We know the cube root of 100 is going to be somewhere in here between cube root of 64 and cube root of 125. When I check it on my calculator, I'm going to check it on my calculator here. Cube root of 100 is going to be 4.64 about. Okay, and then cube root of 180, well, we know that it has to be between these two whole numbers. The side length has to be between 5 and 6. So there's where cube root 180 would lie. And then when I actually do cube root of 180, my calculator is giving me back 5.6, about 65 when I do that. Okay, so we need to be able to estimate. Here I use the calculator to just check my answers and to make sure they're on the right place on the number line. Okay, oh, I put the cube roots on that number line and not instead of this one on the bottom, but hopefully you get the idea.